Hello everyone. In this segment we'll discuss about how to write a Vhdl code for 4-bit up counter. Now in first case we'll discuss about what is meant by counter and then we'll come across how to write it. Now what actually mean by counter? Counter is basically a sequential circuit which is used to count the number of clock pulses. Now if it counts the clock pulses, definitely there must be two possibilities. Either it will count it in ascending order or it will count it in descending order. So depending upon that we can have the basic two types as either up counter or down counter. Now let us see an overlook about its two types. The first type is going to be an asynchronous counter and the second one is synchronous counter. Now what actually mean by asynchronous counter? The counter whose next state output is driven by the previous flip-flop output is called as asynchronous, whereas synchronous counter is one in which the clock pulse change can occur simultaneously. So it can be a definition of synchronous as well as asynchronous counter. Now irrespective of whether it is asynchronous or synchronous, we can write a Vhdl code for 4-bit up counter. As it is a 4-bit, so its output can have 4 output terms as Q3, Q2, Q1 and Q0. As it is an up counter, it should start from the reset condition as 0, then it should go in ascending order as 1, 2, 3, 4, so on up to the 15th condition, and from that it again reset and it comes back to 0. So in this way it continuously exit in a loop. That's why it is called as a 4-bit up counter. Now what are the requirements to design its Vhdl code is going to be, we need a clock pulse and a clear function and we need an output. So let us see its Vhdl code. So first case we will define the library element as IEEE. Now you can use it by this term as use IEEE dot the package as 1164.all. .all is an extension that can be used to access all the components from this package. Now we'll define the entity as up counter is and its port as clock and clear. They are going to be our input standard logic, and Q is going to be the output standard logic vector whose length is 3 down to 0. So it will generate the output terms or bits as Q3, Q2, Q1 and Q0. We'll end it and now we'll move on to architecture behavioral of up counter is. Now in this case, as we are dealing with sequential circuits where output depends upon present and past input, so we'll define a signal called as temp, which is temporarily generated, again which is a vector whose length is 3 down to 0. Here it is, you can say this is 3 down to 0. Now we'll initialize the statement and we'll come across process where the inputs are clock and clear. So I written clock comma clear. Now let us begin the process statement and we'll come across the first condition. If clear is equals to, now if this clear signal is enabled, it simply shows that the output will be in reset condition. That means temporary signal that we have generated will be 0 0 0 0. You can see this is going to be 0 0 0. Else if this condition is not satisfied, we have to switch out to the condition called as if clock is equals to 1 and clock tick event. That means if the rising edge is there and if an event occur on clock pulse, then we have to add 1 to the given sequence. It will start from temp should be less than or equals to 10 plus 1. Now what will happen? Already we have this signal as 0 0 0 0, so when it is added with 1 it will become 0 0 0 1. Now this condition will remain continuous until it is in reset condition. So it will start counting from 0 0 0 0 so on up to the last condition as 1 1 1 1, and finally it will reset. So we'll write end if, because we initialize if statement, we'll end the process statement and we'll return the signal. Now you can see the signal temporary has been generated, that will return to Q. Q is nothing but our output vector, so it will automatically store across Q, and finally we'll end the architecture. So it is going to be end behavior. So in this way we can write the Vhdl code for 4-bit up counter. Now the process to be remembered here is going to be, we have to define a temporary standard logic vector which can store the data from 0 0 0 0 up to 1 1 1 1, and finally it will return it to our output as Q. I hope you understood this concept.